Word problem time. Don't worry, most people are nervous. And to be honest, word problems still get me a little bit nervous because there are so many unknowns that are a part of them. But we'll work through these two, and I can show you how they're, especially if we visualize them with a graph, they're actually not bad at all. So, on with it. Dock jumping is a dog event in which dogs compete for the longest jumping distance from a dock into a body of water. The path of a specific Jack Russell Terrier, oh cute, on a particular jump can be approximated by the quadratic function h at d, so the height at a specific distance, equals negative 3 over 10 d squared plus 11 over 10 d plus 2, where h is the height above the water surface, and d is the horizontal distance of the dog, the dog travels from the base of the dock, and both of these are in feet. Determine the horizontal distance of the jump. So what I've done is, you guys should use this thing. It's called Desmos, it's free. See what I mean? Desmos. It's and it graphs things for you. So this right here is the graph. The dog starts off at 2 above, the dog jumps, and then when the height above the water is 0, we can see that the horizontal distance is 5. Now we want to get to algebra. We want to get to this algebraically, but what I just want to say is, when the height above the water is 0, that's what we want to figure. That's what we want to use to figure out what the horizontal distance would be. So when you see this kind of question, you see, oh my goodness, there are two different kind of variables. There's an h and there's a d. But we want to determine the horizontal distance, so this is our d. So we want to solve for d of the jump. So we want to see when the dog hits the water. That means that the height above the water would be 0. So when we substitute an h equals 0 in, we would get 0 equals negative 3 over 10d squared plus 11 over 10d plus 2. This looks a lot like something that we've done before. Maybe something that you've seen in your homework assignment. But what we want to do first is, because it's an equation, we can use that multiplying by 10. And in fact, if you wanted to take this extension a little further, we could multiply it by negative 10. But we'll deal with the negative a little bit later. But if you want at this point to multiply by negative 10, you go for it. So if I multiply each term and each side by 10, I was going to write it out. 10 times 0 is still just 0. 10 times negative 3 over 10 is just negative 3d squared plus 11d plus 20. So just in the margins, we're going to write down two numbers that multiply out to negative 60, because negative 3 times 20 is negative 60, and we add up to positive 11. One of them has to be positive, one of them has to be negative. The two numbers that are coming to me are 4 and 15. So we want to have the positive on the 15 and the negative on the 4. Now somebody came up to me and asked me, well, what do I put first? Do I say like minus 4x plus 15 or 15x, or do I say plus 15x minus 4? In all honesty, it doesn't matter. You can do the question either way. So if I would write down right here negative 3d squared plus 15d minus 4d plus 20, I can write down minus 4d plus 15d and factor it and be just fine. So just giving you that heads up. So I'm going to factor by grouping here. This one is going to be, I'm going to factor out a negative 3 from both. So I'm going to say negative 3d, and what I'm left with here is simply d minus, because positive 15 divided by negative 3 is negative. So minus 5. And then I'm going to factor out a negative here, and I'm just going to say negative, negative 4, because a 4 is common to both of these. So then I'm left with d, and then if I say 20 divided by negative 4, I'm going to get negative 5. So if I am to give this, if I'm to finish off this question, I would get negative 3d minus 4 multiplied by d minus 5. Now, if I multiplied here by negative 10 all the way through, I wouldn't have to deal with this, minus 3d minus 4. What I can do right now is I can factor it out if it makes me, you know, if it confuses me a little bit less. But you don't actually have to. You can take negative 3d minus 4 equal to 0 to see where the solution lies. But we can do this, 3d plus 4 times d minus 5. You multiply both sides by negative 1. 0 times negative 1 is still 0. Negative 1 times this expression is just that expression. 3d plus 4d minus 5. Boom! So, I know that my answer is going to be d equals 5 or d equals negative 4 over 3 from this one. So let's think about it. Can a distance ever be negative? I guess a distance can be negative when we're talking about physics. But when we say that it starts at a specific origin, we want to make sure that we can conceptualize it like this, saying that we're starting where the distance is 0. We don't start at a distance of negative something. We start at the origin, which is at 0. And it doesn't explicitly state that, but you can assume that somebody's starting point would not be negative. Somebody's starting point would be where distance equals 0. And then you move in a forward direction. So when we take the actual physical constraints into consideration, this d equaling negative 4 over 3 does not make any sense. Just like negative time doesn't make any sense. Oftentimes our x is going to be, or our independent variable is going to be time. You can't have negative time. So we can say with certainty that the total distance is 5 feet, or the horizontal distance is 5 feet. And just for the record, we should get pretty comfortable with this kind of a shape. This is a parabola. It's what's coming up next. We're graphing quadratics instead of solving for them.